Today we will learn about mean, measure of central tendency. To represent a group of numbers, many times we need an appropriate number that represents a group of observations. Such a number is called the central tendency of the group. We use different types of central tendency to interpret different types of data, such as mean, median, and mode. In this video, we will discuss the mean. We usually know the mean by the name of average. It is also called arithmetic mean. The mean of observation of a group is the number obtained by dividing the sum of all observation by the number of observations. For example, the mean of given data is 22. We represent mean as x bar and read it as x bar. If we are given n observations like this, then their mean can be written as. For our convenience, we can represent the sum of observations in this way, where Greek letter sigma denotes summation, xi is a variable where I is any natural number from 1 to n. We read it as summation of xi where I ranges from 1 to n. Here n represents the number of observations. With its help, we can now represent the mean in this way. We use this formula to obtain the mean of the data. Now consider that in observations, frequency of x1 is f1, x2 is f2, x3 is f3, similarly xn is fn. Then we can get the sum of all observations in this way and the number of all observations in this way. Remember that here n represents the total number of observations. In this way, now the mean of these observations can be written in this way. With the help of this formula, we can find the mean for given ungrouped frequency distribution. Now, let's understand some characteristics of the mean. For example, here are the heights of some children. To understand what their average height is, we have to find the mean of all children's height. The mean is the only measure of central tendency that takes into account the total value of the data. Therefore, if we require a scale showing the reflection of the total value, in that case, the mean would be a suitable measure. Similarly, if we have to compare the performance of two batsmen, then it will be more useful to compare them by finding the mean of their runs. Here are some observations. Their mean is 20. If we change the observation 29 and write 7, then with the new observation, mean is 18. In this way, the mean depends on all observations. If there is a change in an observation, then the mean also changes. Suppose in a year, 3 districts of a state receives rainfall of 3 cm, 8 cm, 9 cm, due to which those districts had to face drought. And in 4th district, the rainfall was 380 cm, due to which the districts faces flood. If we find the average rainfall in 4 districts, it will be 100 cm. Looking at this, would it be correct to say that there has been good rainfall in 4 districts? No, it would be wrong to say. The extreme value here is 380 cm, which is much larger than the other observations. It has the most effect on the mean. Similarly, peak values have greater effect on the mean. By observing observations here and their mean, it can also be said that if the peak value in observations is too large or too small, then the mean does not represent the best of observations. In situations when the peak value is too large or small, median and mode helps us, which we will read about in subsequent videos. So today we learned about mean as the measure of central tendency. In the next video, we will learn about another measure of central tendency, that is median. Today we will learn about the median, a measure of central tendency. In the previous video, we saw that we get the mean by dividing the sum of observation by number of observation. Like the mean, the median is also a measure of central tendency. After arranging the data in ascending order or descending order, the middle observation is the median of these data. If we are given n observations, then we arrange them in ascending or descending order. If n is an odd number, then in these observations, n plus 1 divided by 2 will give you the position of the median in the observations. But if n is an even number, then median is the mean of n divided by 2th and n divided by 2 plus 1th observation. For example, suppose one day's rent of living in different hotels in a city is in rupees like this. Let's arrange them in ascending order. Here, the number of observations is 9, which is an odd number. So, the median of these data arranged in ascending order will be 9 plus 1 divided by 2, that is 5th observation, that is 500. Suppose a new hotel started in the same city whose one day stay is 800 rupees. Now, we can arrange all numbers in ascending order in this way. In this case, the number of observations will be 10, which is an even number. In this case, we get mean of 10 divided by 2, that is 5th, and 10 divided by 2 plus 1, that is 6th observation, which will be 525. The median is a middle number, so it divides the data into two equal parts. One half consists of observations whose values are equal to or less than the median, and other half consists of observations whose values are equal to or greater than the median. Now, let's understand some characteristics of the median. Look at these two groups of data. The mean of the first group will be 16, which is a best representative value. Except for one observation in the second group, all observations are similar to the observations of the first group, but that one observation is much larger than the other observations. In this case, the mean would be 27, which cannot be called a good representative value. But here, the median of the data in both groups is 16. Since the values of most observations in each group are around 16, we can say that in both cases, 16 is the best representative value. In this way, when the peak values in the data are too large or too small, the median is a better choice than the mean. At the same time, by looking at the two groups, we also find that if there is a change in the peak value, it does not affect the median. This means that median is not more sensitive to peak values. The median does not take into account the exact values of the data. In this way, it does not use the complete information given in the data. The mean helps in statistics calculation, but the median does not help in this. For this reason, the use of median is limited. So, today we learned about median, a measure of central tendency. In the next video, we will learn about another measure of central tendency, that is mode. Today we will learn about the mode, a measure of central tendency. Mode word is taken from French word la mode, which means trend or fashion. In terms of data, mode is the value that is most prevalent. Like if we talk about these observations, then here 12 is the most frequent. In this way, we can say that 12 is most prevalent among this group of observations. That is, 12 is the mode of these observations. Now look here. Here, the marks obtained by the children in a competitive examination are given. There are a large number of observations here, so it will not be easy to find the mode by looking at the numbers. For convenience, we can arrange the data in a frequency distribution table in which we write the number and show it by its tally marks and the number of times it has appeared in all observations. The count of tally marks tells us the frequency of that number in observations. Can we identify a mode based on frequency? Think. Absolutely right. The frequency of an observation tells us how many times the observation has occurred in all the observations. So, the observation that has the highest frequency will be the most frequent in the observation group, that is, the most prevalent. Therefore, observations with maximum frequency can be called mode. As here, 35 observations have come at most 10 times, so it is mode. Here, mode 35 tells us that the maximum number of children have scored 35 marks. Suppose there were 6 more children who got 32 marks. Then, in this case, the number of children who got 32 marks would be 10, which would be equal to the number of children scoring 35 marks. In this way, there would be 2 observations in the group that had the same frequency and the highest. In this case, we would have received 2 modes. Hence, modes can be more than one. Now, let's understand the characteristics of mode. The mode is not affected by peak values of the data. Look at these 2 groups of data. Here, in the second group, the peak value is 698, which is extremely large, the remaining numbers being the same. If we find the mean of each group, we see that due to extreme value 698 in the other group, the changes are taking place in the mean. If we find the mode of these 2 groups, then it is 22.4. You can see that mode is more suitable here than the mean to represent the central tendency. The mode can be used for both quantitative and qualitative data. We have seen examples of quantitative data. Let's look at the example of qualitative data. Suppose a family wants to buy a car. Following are the opinions of the family members regarding the color of the car. Their mode is black color. So, with the help of mode, here will help in making decisions related to color of the car. There are some collections of data in which all observations are repeated the same way, or there are 2 or more modes in the data. In such a situation, the mode is not useful measurement. For example, if the colors of the car were selected by the members of the house in the following way, would it help us to make decisions related to color of the car? Think. Here each color is repeated twice, so choosing one color will not be easy. The mode is commonly used by the ready-made garment industry and shoe industry. Mode helps them to decide which size or measurement should be produced in greater numbers. So, today we learnt about mode, a measure of central tendency. In the next video, we will see some interesting examples on the central tendency of data, mean, median, and mode. Today we will see examples on measures of central tendency, mean, median, and mode. The government organized a free medical checkup camp in a village. The blood sugar level of diabetic patients during the examination is shown below. Find the mean of the data presented. Here, we are given observations and their frequency, so we should use this formula to get mean. Here, x bar is mean, xi is observations, fi is frequencies, and n is the number of entries in the table. Here, n is equal to 5. Here, we will make the table like this, where in first column, we will represent xi means observations, in second column fi means frequency, and in third column we will represent multiplication of observation and frequency means fi/xi. Here the sum of the frequency of observations is 30, which means that a total of 30 diabetes patients were tested for blood sugar level. Now for each observation we will find fi/xi means fi multiplied by xi. For first observation, f1x1 is equal to 125 multiplied by 5 is equal to 625. Similarly, we will find fi multiplied by xi for other observations. We will find sum of fi/xi where I ranges from 1 to 5, which will be 4674. In this way, mean is equal to 155.8. Next example, the figures in the given data has been arranged in ascending order. If the median of these figures is 56, then find the value of x. The total number of observations in the data shown is 8. The number 8 is an even number. We know that if number of observation n is an even number, then median is mean of n by 2th and n by 2 plus 1th. Therefore, here the mean of 4th and 5th observation is the median. Here, the 4th observation is x plus 3 and the 5th is 2x minus 11. Therefore, median is equal to x plus 3 plus twice x minus 11 divided by 2. From the question, it is known that median is 56. Therefore, we can write this as, simplify this as, we get a value of x as 40. Next example, 11 students of a class participated in the Science Olympiad of 200 marks. The marks obtained by these 11 students are as follows. So, can you tell which measure of central tendency would represent these figures well? A measure that represents the entire set of data with a single value is called a measure of central tendency. We know about mean, median, and mode are measurements of central tendency. To find the representative value of data shown, we will find the value of each measure of central tendency. Here, mean is 84.09. Now, to find the median, we will arrange the data in ascending order in this way. The total number of observations here is 11, that is odd number. Therefore, median is 6th observation which is 73. Each observation occurs only once in the group of data shown. Therefore, each observation of group of data is mode. Now, if we compare the three measurements, we see that most of the students have less than 84 marks. Therefore, no approximate estimation of students' marks is obtained from the number 84.09. This is because the numbers 52 and 175 are the extreme values here. The difference between some statistics in the group of data is very large. Therefore, the mean is not a perfect representation of this set of statistics, and the mode of this set of data has no definite value. Therefore, the mode is also not a perfect representation of this group of data. Now, if we talk about the median, the value of median is 73. Here, the number 73 is more effectively representing the marks obtained by the students, and the extreme value of 175 is not having much effect. Hence, median 73 is the best representation of this group. So today we have seen examples of central tendency measurements, mean, median, and mode.